Hey guys, Mr. Backberg here. In this video, we're going to look at graphing using intercepts. So when we're talking about intercepts, there are two different kinds of intercepts that a function or a graph can have. First, there's an x-intercept, and that's the place where your graph crosses through the x-axis. And your x-intercept as an ordered pair will always look like some x value, comma 0. And it's always going to have 0 in that y position because it's the place where your line is crossing through the x-axis. So we haven't gone anywhere up or down. We're just looking for that specific x value where your line crosses through the x-axis. Similarly, we have a y-intercept, and that's the place where your graph crosses through the y-axis. And your ordered pair for a y-intercept will always look like 0, comma, some number. It will always have a 0 in that x position, and then we're finding the y value where your line crosses through the y-axis. So if we look at a graph, we can visually find the intercepts by looking at where your line is crossing through each axis. And we're always going to write our intercepts as ordered pairs. So let's do the x-intercept first. So remember, your x-axis is your horizontal axis, and to find your x-intercept, we're trying to find the place where your graph crosses through that x-axis. So I'm focusing on this point right here, and I'm highlighting it in red right now. We're trying to figure out where our line crosses through that x-axis. So if we count from the origin, this is over 1, 2, 3, 4, 5 spaces. So that would be the ordered pair 5, 0. So this graph's x-intercept is at 5, 0. Now we can also find the y-intercept where your line crosses through the y-axis. So I'm highlighting this point in blue right now. From the origin, that intercept is up 3 spaces. So that would be the ordered pair 0, 3. So we would say the y-intercept of this graph is the point 0, 3. Another example to take a look at, and we're going to find the x-intercept first. So this point on the left-hand side where our line is crossing through the x-axis. Counting from the origin, that point is to the left 3 spaces. So that's going to be the ordered pair negative 3, 0. So that's our x-intercept. And then if we want to find our y-intercept, where our line crosses through the y-axis, that's this point that I'm highlighting in blue. From the origin, that's down 1 space, so that would be the ordered pair 0, negative 1 as your y-intercept. Now we can also use intercept information to help us draw out a picture of a graph. So for example, if we knew that a line had an x-intercept at 3, 0 and a y-intercept at 0, negative 2, we could plot those points out and then connect those points with a line to draw the graph. So since we have an x-intercept at 3, 0, that means that we're crossing through the x-axis at that x value of 3. So the point 3, 0 from the origin is to the right 3 spaces, but then don't go anywhere up or down. We're just directly on that x-axis. And that should make sense because this is an x-intercept where we cross through the x-axis. Then our y-intercept is at the point 0, negative 2. So from the origin, don't go anywhere left or right, but go down 2 spaces. So there is our y-intercept. Now I should be able to take that and connect that with a nice straight line. And then I'm going to put arrows on the ends of my lines to show that it does extend forever and ever and ever. So that is the graph given this information. So another example here of drawing out a graph given the intercepts. So we know that the x-intercept is at negative 1, 0. So from the origin, I go left 1 space, and I'm going to put my dot right there. Then we know that our y-intercept is at 0, 4. So from the origin, I go up 4 spaces and put that dot there. Then I can go ahead and connect these with a nice straight line. And I'm going to put my arrows on the ends of my line to show that it extends forever and ever. And this is the graph given those intercepts. Now we can also find intercepts of a graph by looking at the equation or the function. So in this example, we're going to find the x-intercept for the graph 2x plus 7y equals 28. Now remember, an x-intercept always looks like some x value, comma 0. So an x-intercept always has a 0 for the y value. So algebraically, if we want to find the x-intercept, then we're going to plug 0 in for y. And then what we're going to do from there is solve to figure out what our x value is. So in this equation up here, we're going to plug in 0 for that y value. So we get 2x plus 7 times 0 equals 28. Now we're going to solve to figure out what our x value is. Well, 7 times 0 is just 0. And if I take 2x and I add 0 to it, that kind of cancels out in there. So we just get 2x on the left-hand side, and that equals our 28. Now, if I want to get x alone, I have to get rid of that 2 that's in front of the x. So I'm going to divide both sides by 2 to cancel that out. So I'm going to get x equals 14. Now, we always want to write our intercepts as an ordered pair. So this ordered pair, we started by plugging in 0 for the y value. So I'm going to put 0 in the y position in the ordered pair. And when we did that, we got an answer of 14. So that's what goes in the x value there. So the x-intercept of this graph is at the point 14, 0. Now in this example, we're going to do something similar, but we're going to be finding the y-intercept for the graph. So remember, for a y-intercept, the ordered pair always looks like 0 and then some number for our y value. So in order to solve algebraically to find the y-intercept, because we have an x value of 0 in the ordered pair, we're going to plug in 0 for x. And then what we're going to do, because we're trying to find our y value answer, is we're going to have to solve to find that y value. So in this equation, I'm going to plug in the 0 for the x value. So we would get 2 times 0 plus 7y equals 28. Now 2 times 0 is 0, and if we add 0 to 7y, then we just get 7y on the left-hand side, and that equals 28. We have to get rid of the 7 in front of the y, so we're going to divide both sides by that 7. When we do that, we get a y value of 4. So now building this ordered pair, we started by plugging in 0 for the x. So in the x value, I'm going to put in 0. And then we solved to get y. We got an answer of 4. That's our y value, so that goes in the y position of the ordered pair. So the y-intercept is at the point 0, 4. In this example, I want to find both the x and the y-intercepts for the function y equals 4x plus 12. I'm going to split my screen to do this, and I'm going to do my x-intercepts on the left-hand side, and I'll do my y-intercept on the right-hand side. And I'm going to start with the x-intercept, and we said to find the x-intercept, what we want to do is plug in 0 for the y value, and then solve to get x alone. So if I plug in 0 for the y, we would get 0 equals 4x plus 12. Now I want to solve to get this x alone. So I see this plus 12 happening over here on the right-hand side. I'm going to subtract 12 from both sides. So that 12 on the right-hand side cancels out. On the left-hand side, 0 minus 12 is negative 12. And now on the right-hand side, all we have left over is that 4x. I want to get rid of the 4 that's attached to the x, so I'm going to divide both sides by 4. When I take negative 12 and divide by 4, we get negative 3 as our x value. So now writing this as an ordered pair, the x value was negative 3, and the y value, well, we plugged in 0 for the y value, so the y value is 0. Now as far as the y-intercepts go, we want to plug in 0 for the x value. So we would get y equals 4 times 0 plus 12. Well, 4 times 0 is 0, plus 12 is 12. So we get y equals 12. And again, writing this as an ordered pair. Now we plugged in 0 for x. So the x value for the ordered pair is 0. And we got a y value answer of 12. So that's the ordered pair 0, 12. So now if we wanted to, we could graph this function by plotting both of these ordered pairs out on our grid and then connecting them with a line. That's going to be it for this video. Thanks for watching.